Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question number 20, which is from the Analytic Geometry section.
It says, determine the shortest distance from the point 2, 1 to the line defined by this equation. So you can see I've already graphed what's going on. I can't really understand a question if I can't see it, and definitely it's easy to understand what we're about to do. I can explain it to you better if I have a diagram. So I graphed the line. Here's the line, and it was pretty easy to graph, right? It has a y-intercept at 7, down 1 over 1, down 1 over 1. There's the line. Labeled it nicely because I like to get a lot of marks. And then I decided to call this point P so that it has a name, and I graphed point P there. And since I'm naming things, let's actually call this line 1 so that it has a name as well. So our job is to find the shortest distance from this point to this line. So think for a minute about this line. It is infinitely long. So, I could find the distance from P to the y-intercept. I could find the distance from P to the x-intercept. I could find the distance from P to a point over here, and so on. So there's lots of different ways that I could find the distance, but those are usually not very helpful. What we want is the shortest distance between the point and the line. And the shortest distance is perpendicular distance. So from P to the line, if I draw a perpendicular line, so instead of those other lines, which were just kind of random, this line here, not the one I'm trying to delete, give me a second, let's get rid of this fake line, bye-bye. This blue line, oh, it's still there. Perfect, never happened. This blue line is the shortest distance. Hopefully you can just see that visually, but it also is by definition the shortest line because it's perpendicular and therefore it is the shortest distance. So we need to find the length of that blue line. So how are we going to do that? Well, that blue line, and I'm just going to draw perpendicular so we know, that blue line goes from P to a point right here. And I'm pretty sure, let's call that point Q. We want to give it a name, right? If we're going to talk about it, it has to have a name. So from P to Q, I need that distance. So to find distance, we have a formula. Here it is. So we need to know the distance from P to Q. Great, there's my formula. But there's a problem. I don't know what the coordinates of point Q are. And I'm not going to just look at my graph and guess what they are. That's not what we do in academic high school math. We have to algebraically calculate the coordinates of point Q. And so how are we going to do that? Well, let's talk a little bit more about this blue line. We know that this blue line is perpendicular. Right now, it's actually a line segment. So let's make it into a whole line. So let's actually take this blue line segment and extend it. So there, now it's a proper line. So now I'm going to call it something. I'm going to call it line 2. So what do we know about line 2? Line 2 passes through P, passes through Q, and is perpendicular to line 1. And that's enough information for us to find the equation of line 2. And don't worry about why we need the equation, because to be honest with you, if you have no idea how to do this question, at least you know how to do something. And what I always tell my students is if you have no idea how you're going to get to the final answer, then don't worry about it. Get somewhere. Do something mathematical and hope that that process will eventually show you the way. So I'm going to find the equation of line 2. So again, we know that line 2 is perpendicular to line 1. So there's perpendicular to line 1, and it passes through points P and Q. Now, it's not that useful to me that it passes through point Q right now because I don't know anything about point Q. But I do know that point P has coordinates 2, 1. So there's a point on my line. Now, if line 2 is perpendicular to line 1, then we can talk about slopes. And again, if you look at this equation, it's pretty clear that the slope of line 1 is equal to -1. And so therefore, the perpendicular slope must be +1. That's pretty easy. So look at what I have. For line 2, I know the slope right here, and I know a point it passes through. And you know from grade 9 and lots of grade 10 work, well, that's all you need. So let's do the math. We're going to find the equation of line 2. And again, every line starts like this. And I know what the slope is. The slope is 1. So really I have y equals 1x plus b. And now I have a point, 2, 1, that I can substitute in. And x is 2, y is 1, and that'll let me solve for b. So, double substitution. Always substitute with brackets. So x is 2, y is 1. So I have 1 equals 2 plus b. Solve for b. Oops, that's not true. Boy, oh boy. What's going on? See, that's why you do math in pencil, right? Because mistakes happen. There's the value of b, and that means I know the equation of line 2. It's y equals x minus 1. Excellent. So let's go back to my diagram. I now know, and again, it's nice to have a diagram because I can make sure that my math is right. Does this look like the right equation with a y-intercept of -1 and a slope of 1? Yeah, it sure looks like it. So why did I need that equation? Well, don't forget, the whole point of everything was to find the distance between P and Q. Oops, this black little line here. And we'd already said to find the distance between P and Q, we're going to use this formula. But in order to use this formula, I need the coordinates of Q. So look what I have now. I now have line 1 and its equation, line 2 and its equation, and that means if I have two equations, I can find their intersection. And in this case, their intersection is Q. So that's the next step. So I'm going to take line 1, which has the equation y equals -x plus 7. And I just found the equation of line 2. It's y equals +x minus 1. And I'm going to solve. So I want to know where they intersect. So pretty easy to do. I'm going to add these equations together. Y plus y is 2y. -x plus x is nothing. 7 minus 1 is 6. So 2y equals 6. Y equals 3. And now find what x is. So I'm going to sub y equals 3 into L1. And that'll help me find x. So again, line 1 said y equals -x plus 7. And now I know the value of y is 3. So I do the substitution. So 3 equals -x plus 7. So -4 equals -x. So x equals 4. And just like that, I know the coordinates of Q are 4, 3. And again, look at your diagram. Does that make sense? Oh, I've kind of messed up the diagram. Let me do a little bit of tidying up here. See? Erasing is fun. Now, that definitely looks like the point 4, 3. And that's point Q. And now, finally, I have the coordinates of P, I have the coordinates of Q, and I can finally find this distance. And again, I'm going to do that using the distance formula. So here we go. Almost done, and it only takes me one video. Woof. So P was the point 2, 1. Q was the point 4, 3. And let's grab the distance formula. You have it memorized, but just in case, there it is. And so now, the distance between P and Q. So the distance PQ is the square root of, I don't even have fractions. Nice question. So x2 minus x1 squared plus y2 minus y1 squared 4 minus 2 is 2. 3 minus 1, oops, is 2. That's a little 2. So 4 plus 4. So I have the square root of 8. And again, check with your teacher. Do they want decimals at this point? If they don't want decimals at this point, then we will reduce the fraction. The biggest perfect square, so 2 squared, 3 squared, 4 squared, 5 squared, etc., that evenly divides 8 is 4. So I'm going to rewrite 8. It's 4. Square root of 4 times the square root of 2. And what's the square root of 4 again? Oh, it's 2. So the answer is 2 root 2. And again, if your teacher didn't do this, then stop here and maybe give the decimal. I'm not sure. But there you go. Done the question. That was nice and easy. My favorite question so far. Yay! If you have any questions, just ask either in the comments section or come see me at school. Oh, I even have time to draw a pretty picture. All right. Good luck studying. Bye-bye.